Hi everybody. Haven't uploaded in a while. Been real busy working on several different things. And one of the things I have been working on is obviously text to speech and speech to text using the Google Cloud APIs. So what this video is about is several different things. I have grafted or merged several different Python code examples to get a chat bot that uses the AIML, the old AIML um, chatbot engine to where you can talk to it. So I'll do a quick demo to get people to where I'm at. So this code that we're looking at here, it is in Python. Most of my projects now are going to be using Python simply because I'm using Keras and TensorFlow, and a lot of that code is just Python based, and it's really a pain to try to get any of this stuff to work in C#. So the past couple of months I've been getting up to speed with multi-threaded Python and also recreating what I have done in C# in Python as well. I've also looked at some conversational NLP training, and that's a whole other thing. So anyway, let's get this thing going. One caveat with this code is I'm currently working on a way to use what they call voice activity detection to turn the recording on and off based off of human voice. I'm currently going to be hitting a key every time I want to uh, chat with the bot, which is subpar, but again, I'm still working on the code. I'm using idle. This is Python 3.6, and I'll go into a little of the details on getting everything installed. But you basically run. What it's doing is the code is pulling in the AIML precompiled brain so the chatbot will work. And this chatbot in Python was a console application. So what we're going to do now is we're going to talk to it. So during this recording, you're going to hear this low voice. That's actually the chatbot chatting back, and we're sending information from our computer up to Google, back down to our code, and then back up to Google, and then back down for the voice synthesizing. So here we go. Hello.
Hi there.
So you notice there's a little bit of speed delay, but it will speed up. Tell me a joke.
What I want to tell you is how much fun it is talking with you.
Well, I enjoy talking to you. Do you have a name?
I get a great deal of pleasure from chatting with people online. You are not the boss of me.
What's your name?
Are you asking about my name?
Yes.
I don't want to talk about that now.
What did you do yesterday?
I talk to people on the web. What do you do?
I program you.
Have you tried AIML?
We're running it right now.
Do you think I am running it too?
Yes, you are AIML.
I think there might be a few exceptions.
Tell me a joke.
I don't know how to explain it to you.
I'm showing everybody online how you work.
I thought you were, but I wasn't completely sure.
I've got to go.
Bye.
Okay, so that is kind of a bizarre conversation that you can have with this AIML chatbot. The only difference is that we're not using the keyboard to type in the chat responses. We're using voice, and we're using the Google Cloud voice to text and text to speech APIs in real time. And the only thing that we have that I don't like is getting the voice activation working, and I'm currently hitting the keyboard. I have been working on that code. It's not ready for prime time. It's pretty complicated as far as getting the timing right, and it's by no means production quality, but I've been learning a lot about how things doing multi-threaded programming in Python, and that's what it involves. So what I'm going to do right now, if you're still watching and you're still interested in this thing, is go through this code. I didn't take the time to clean the code up and maybe make a class. There's some redundant code in here, or there's a redundant pattern that's going on in here to where it could have been cleaned up. And I don't really understand why Google's API is cracked. It's in two different pieces. So basically, if you pull down the Google source, if you go to their GitHub, I think I lost it. Okay, we'll just talk about the AIML chatbot first. The AIML chatbot, you basically, this is how I started. You can pull this down. It has nothing to do with Google, but you can see some of the code of what I merged with, and you can do pip install on this. You can look it up online. It's on GitHub. You can pull it down in a couple of minutes, and you can be typing and get some of the same responses. Let's go over to, there's the README on this Google, or I'm sorry, on this AIML chatbot. Again, it's in Python. There you go. There's a pip install. I'm not going to go into detail on how to program Python and how to do pip install or anything like that. If you don't know how to do that, then you probably shouldn't be watching this video. You need to get up to speed with that first. But that's how simple it is to get AIML, and then I also did the pulled the source. Okay, you're gonna see a bunch of screens flickering, but so what we got to do right now is we have to pull in three different coding examples. One was the Google speech example. One was the Google text-to-speech example. The Google speech example will take your voice audio and turn it into text. That's what we want because the AIML chatbot works with text. But we're not going to be typing on the keyboard. We're going to be taking whatever Google speech returns, and we're going to be sending it into AIML. So AIML looks at the text that we sent to it, and then it generates a response based off of its engine. I won't go into a lot of detail on that. And then now we have text that came back from the AIML chatbot. So then what we do is we take that text, we send it back up to Google, and we have Google translate it into a waveform, an audio waveform. Now, what you'll notice is the voice of the as it comes back, as it gets translated, it's Google does it right, and I actually save it to a file, and then I load it back in, and I'm using Pygame and PyAudio. And Pygame has an issue to where you've got to get your sample rates and everything right, or it won't um, play back the audio correctly. But if you actually get all this stuff working, you'll notice the file as what was said on in your directory as this thing's running, and get rid of that, and you could play that audio and it sounds perfectly fine. So what you'll start seeing in here, we have the AIML chat code that has to go in here to where it has to load the brain. And so it's getting to the point to where it's ready to listen to the command line, but we're not going to send anything command line. I broke this out to where you can make a little bit more sense of the using the Google Speech client and the Google Text-to-Speech client. So there's two different clients here, which I think is kind of goofy on Google's side, but they got the things broken out, and this is probably would be nice to be put into a class. So as you can see, you if you take the Google examples apart in the Python code, you'll see some of these same lines here, but I've kind of changed some of the settings. The next thing we have to do is we have to set up the Pygame engine, audio engine, because we're going to use that to play back the audio. There's a way to do this with PyAudio, but I haven't gotten it to work right. And there's a million examples of how to use PyAudio for audio in and audio out. Later on, I'll try to get it working to where we don't have to use Pygame. So we're going to go into this loop, and as you can see, we're waiting for the keyboard to be hit right here. This code will eventually be changed with another maybe event loop that will tell this process to start when there is voice activity. And there's not only voice activity, but here is the chunk of waveform audio that you need to send to Google. That's currently not happening in this code, but I want to try to get that done, and I think that would be slicker for demo purposes. So this is boilerplate PyAudio code to set up the audio stream to get your audio in. And while this is basically starting to record, and it's basically building an array of chunks of the samples for a certain amount of time right here. And that is a variable that we can set up top, and you can change that at will. Once we get all that data, we shut the streams back down. Again, this is code that's it's online. It's no big deal. Their examples they have to write. Currently, I don't have it figured out how to just take the wave data and send it to Google. It's in this different format, so I'm writing it out to a wave file and then I'm reading it back in. I realize that's highly inefficient, but I have solid state drives, so and I have a very fast internet connection. So if you possibly can get any of this stuff to work, you're going to have a Google account, just like on my other demos, and you're going to have basically these samples work. Before you even try to run this code, you need to get the Google speech to text and text to speech working on your end before you even try to get this code to work. So now what we're doing is we have a audio recording that's on the disk of what we just said. So now we got to ship it off to to Google to get them to do the conversion. That's these couple lines here with the speech recognition client, and then we're going to wait for the response. And as the response comes back, we're doing a very naive uh, uh, operation on pulling out the transcript, which should be text. And then what we do is we have this is the text, and this would normally come from the your console, your keyboard, and we just take that and we send it to AIML. Now AIML runs on our machine, so it's relatively fast, and then it has its response. As the response comes back out, I print out what AIML is responding to. Then we send back up to Google to their text-to-speech synthesis output. And yeah, I know Google has a BERT now that they open sourced, and they have WaveNet and they have all this other super cool stuff. You're exactly right. Knock yourself out trying to get it to work. That's why half of this stuff has taken me so long, because it takes a while. So we've gone back up to Google, and then we get the audio response back from Google. We write that back out to disk, and then we play the sound. I'm sorry, this writes it out to the disk, and then we say, hey, Pygame, go play that WAV file. And now the other thing I'm doing, and part of this robot brain thing that I've been thinking about and working on, is to have the number one is have the chat engine separate, kind of abstracted out from the processing of the, however you want to process the text, or the audio in and the audio out. And if you want to use Google APIs, then you use Google APIs. So the next version of this video is going to have a cleaner interface to your text-to-speech, speech-to-text client. That needs to be one class, and that needs to have a clean interface, because you may want to use some other service. And then your chat engine, or your natural language processing engine, whether you use Rasa or Snips or whatever. The other thing I'm looking at is Deep Pavlov. Then that is in the background handling things. And so this code, the driver code, is very clean, and it's very simple. But as this robot thing is talking to you, what I added to the code was a very simple state. Forget whatever the word is. I'm logging what has been said, who has said what, and in the directory where this thing runs, you will see these files that you could keep track of the conversation. So the next time you run the robot, the chat client, whatever you want to call this thing, it's going to have a log of what was said, who you were, what your name was, and things like that, and then it can try to kind of carry on the the conversation. So it has a little bit of mem or e. It has a little bit of a a chat history. Okay, finally came to me. So this is really raw. I've had this code for a couple of weeks. I'm working on what they call the VAD, voice activation part of it. I'm also working on for a couple of weeks, I worked on a Python to C# bus and a Python face detection bus. And what I mean is a message queue. And it turns out that there's people that are doing some of the stuff I'm doing, and they're using some other tools. So uh, I'm getting up to speed with that. I'm going to have another quick video out on Unity to Python bridge. When or if you ever want, as you're chatting with this thing that is right here on your screen, have that happen inside of Unity. So now you can put a three-dimensional face, and you can make eye contact and stuff. That's a whole other video, and it's a lot of this stuff's coming together. So anyway, I'm kind of rambling. Let me go to the what is this? It's not that. Okay. You may have seen this previously, but you got to go to Google Cloud. I'm not going to go into detail on how to install the Google speech to text, text to speech. If you want to get this working, you kind of have to know how have all this already set up. Here's the GitHub that I pulled down, and you can see the two different examples right here and right here. So this one and this one are the two different examples, and that I pulled apart. It's Google's code, and I just merged them into the one file. And so you've got to get this working first before you can get my code working. And that obviously means you have to give them your credit card, you have to get your Google key generated, and you have to download it, and they go through all that detail in here. If you don't have the patience to do that, then you're more than welcome to just watch my videos. But please don't email me and say, hey, I want you to set all this up for me. I'll be glad to do it, but I'll charge you $100 an hour, and it's going to be a couple hours to do it. So I do have a full-time job as a professional software developer during the day. I'm trying to get this video out as fast as possible. I will be putting the code up on GitHub. I'm going to wait, obviously, to see if I get any traction at all on, this video or any interest. And if I don't, I might put it out there. I might wait for the second version. Anyway, if you've gotten this far, I really appreciate it. Again, this is totally a hobby, but this is the beginning of trying to have a conversation with a computer using natural language processing engines, using text to speech, speech to text. It's a multi-threaded Python code, and there's probably going to be several different pieces of code running on what they call this 0MQ bus to keep it all multi-threaded and running seamlessly. So no, it's not going to run on your phone. No, you're not going to be able to take all this code and put it on a phone and make $1 billion. But what you are going to be able to do is to understand how this stuff works, and then as a prototype, then you can distill it down into 2 or 3 different platforms. A lot of this code probably needs to just be running in a VM instance in Google's cloud, and that's another option I'm thinking about doing, and that way it's 90% of the processing is up there. Anyway, I hope you enjoyed it. Thanks for staring at the screen. Have a great day, and we'll have another video out shortly.